Hello everyone. In a previous class, we discussed about the series and parallel configuration of the diode. In this lecture, we will study about diode testing. How to test a diode, how to test a diode using a digital multimeter. How to test a diode using an analog multimeter. After this, we will move on how to test LED, means how to test light emitting diode. After this, we move how to test a Zener diode. And finally, the reference of this presentation. So let's start with the topic Introduction of Diode Testing. In this lecture, we will learn how to test a diode. Diodes are one of the basic and important components in electronic circuits that are used for protection, rectification, switching, and many other applications. Actually, the definition of the diode is a two-terminal, unidirectional, uncontrolled device. They are one of the fast components to be damaged in case of a fault, and hence it is necessary to know how to check whether a diode is properly working or not. Before the assembling of basic components, it is advisable to test the components about their working condition or the functioning rather than after assembling, to avoid the condition of getting the undesired outcomes. In other case, after successful assembling of the circuits, usually we anticipate desired outcome from the circuit. But sometimes we get unexpected results. In both the cases, we need to conduct some testing procedure for the main components in the circuit to know their proper working. So, let us look on how to test a diode. Next topic is test. The diode is a two-terminal semiconductor device that allows the current only in one direction. These are found in different applications like rectifiers, clampers, clippers, and so on. This is the symbolic representation of the diode as well as the practical diagram of the diode. Its two-terminal name is anode and second is cathode. When the diode terminal is made positive with respect to the cathode, the diode gets forward biased, and the forward biased diode voltage drop is typically 0.7 volt for the silicon diodes and 0.3 for the germanium diode. The testing of this device is made to know its proper working condition in forward and reverse bias modes. Before testing of the diode, we have to identify the terminals of the diode, that is, anode and cathode. Most of the P and junction diodes have the white band on its body, and this white band side terminal is the cathode, and the remaining one is anode. Some diodes may have a different color band, but the color band side terminal is the cathode. The testing of the diode can be carried in the different ways. However, here we have give some basic testing procedure of the diode. Note that the below testing procedure are only for normal PN diode. Next topic is how to test a diode using a digital multimeter. The diode testing using a digital multimeter, in short DMM, can be carried in two ways because there are two modes available in digital multimeter to check the diode. These modes are number 1 diode mode and number 2 ohm meter mode. So number 1 is diode mode testing procedure. This is the diagram for diode mode testing using digital multimeter. Firstly, identify the terminal, anode and cathode of the diode. Keep the digital multimeter in diode checking mode by rotating the central knob to the place where the diode symbol is indicated. In this mode, multimeter is capable to supply a current of 2 milliampere approximately between the test leads, or we can say that the probe. Keep the digital multimeter in the diode checking mode by rotating the central knob to the place where the diode symbol is indicated. In this mode, multimeter is capable to supply a current of 2 milliampere approximately between the test leads, or we can say the probe. Observe the reading on meter display. If the displayed voltage value is in between 0.6 to 0.7, since it is silicon diode, then the diode is healthy and perfect. For germanium diodes, this value is between 0.25 or 0.3 volt. Now, reverse the terminal of the meter. That means connect the red probe to cathode and black to anode. This is the reverse bias condition of the diode where no current flows through it. Hence the meter should read 0L or OL, which is equivalent to open circuit if the diode is healthy. If the meter shows irrelevant value to the above two condition, then the diode is defective. The diode defect can be either open or short. Open diode means behave as an open switch in both reverse and forward bias condition. So no current flow through the diode. Therefore, the meter will indicate OL in both reverse as well as the forward bias conditions. Shorted diode means diode behaves as a closed switch. So the current flows through it and the voltage drop across the diode will be zero. Therefore, the multimeter will indicate zero voltage value. But in some case, it will display a very little voltage as the voltage drop across the diode. The next one is ohm meter mod testing procedure. Similar to the above method, it is also a simple method to check the diode whether it is good, short or open. So this is the diagram. Diode forward biased by ohm meter show zero resistance. Firstly, identify the terminals anode and cathode of the diode. Keep the digital multimeter in resistance or ohm meter mode by rotating the central knob or selector to the place where the ohm symbols or resistor value are indicated. Keep the selector is low resistance, maybe 1 kilo ohm mode for forward bias, and keep it in high resistance mode, for example 100 kilo ohms, for reverse bias testing procedure. Connect the red probe to the anode and black probe to the cathode. This means diode is forward biased. When the diode is forward biased, the resistance of the diode is so small. If the meter display a moderately low value on the meter display, which may be a few tens to few hundred ohms, then the diode is good and healthy. Now, reverse the terminals of the multimeter such that anode is connected to black probes and cathode to red probes. So the diode is reverse biased. This is the diagram for diode is reverse biased by ohm meter show infinite resistance. If the meter shows a very high resistance value or OL on meter display, then the diode is good and function properly. Since in reverse bias condition, diode offer a very high resistance. From the above, it is clear that for proper working of the diode, digital multimeter DMM should read a very low resistance in forward biased condition and a very high resistance or OL in reverse bias condition. If the meter indicate a very high resistance or OL in both forward and reverse bias condition, then the diode is said to be opened. In other hand, if the meter reads a very low resistance in both the direction, then the diode is said to be shorted. Next topic is how to test a diode using analog multimeter. This method is similar to the testing of the diode using digital multimeter ohm meter mod. This is the diagram for analog multimeter. Case number 1 is called for forward bias and case number 2 represent the reverse bias condition of the diode. So keep the multimeter selector switch in low resistance value. Connect the diode in forward bias condition by connecting the positive terminal to anode and negative terminal to the cathode. If the meter indicates a low resistance value, then it says that the diode is healthy. Now put the selector is high resistant position and reverse the terminals of the meter by connecting positive to the cathode and negative to the anode terminal. In this case, the diode is said to be in reverse bias. If the meter indicates OL or a very high resistance, then it refers to the perfect condition of the diode. If the meter fails to show above readings, then the diode is said to be defective or bad. This is about simple PN junction diode testing using digital and analog multimeter testing procedure, not same for all type of the diode. So now let us see how to test an LED and Zener diode, means light emitting diode as well as the Zener diode. So next topic is how to test light emitting diode, in short LED. As discussed above, before testing any diode, we must know the polarities. The LED polarities can be identified by the length of the leads. Longer one is anode and the shorter one is the cathode. Also, another method is the surface structure, wherein the flat surface indicates the cathode and remain one is the anode. So you can see the diagram. In this diagram, we show the terminal identification. Means LED has two terminal, name is anode and cathode. The first diagram you can see the LED terminal, positive terminal is known as anode and negative terminal is known as cathode. Next one is a symbolic representation of LED, means light emitting diode, and third one is a practical diagram or physical diagram of the LED. So longer leads is represented as an anode and shorter lead represent as a cathode. So by using this we can easily identify which terminal is a anode and which one is called cathode. Let us see how to test an LED using a digital multimeter. Firstly, identify the terminals anode and cathode of the light emitting diode. Second, place the multimeter selector in diode mode. Next, connect the probes of the meter to LED such that it is forward biased. If the light emitting diode or LED is working properly, then it glows. Otherwise, the LED is defective. Reverse bias testing cannot be possible with LED since it doesn't work in reverse bias condition. The next topic is how to test a Zener diode. As compared to the testing of normal diode, the Zener diode testing needs some extra circuitry because the Zener diode conduct in reverse bias condition. only if the applied reverse voltage is more than the Zener breakdown voltage. So this is the circuit diagram for testing of Zener diode. For testing of Zener diode, we need multimeter and the extra circuitry shown in a figure. In this circuitry, we need variable power supply, 100 ohms resistance, and the Zener diode. And connect the circuit according to the figure. The procedure for testing a Zener diode: number 1, identify the terminal anode and cathode of the Zener diode, and its identification process is similar to the normal p-n junction diode. Connect the test circuit as shown in a figure above. Place the multimeter knob in a voltage mode. Connect the meter probe across the Zener diode as shown in a figure. Gradually increase the input supply to the diode and observe the voltage on the meter display. This reading on the meter must be such that as we increase the variable supply, meter output should increase until the breakdown voltage of the diode. And beyond this, point meter should show a constant value of voltage irrespective of any increase of the input variable supply. If it's so, then Zener diode is healthy, otherwise defective. Suppose if we apply a 12 volt to the Zener diode, the breakdown voltage is 6 volt. From the battery through a resistor, then multimeter must show a reading which is approximately equal to the 6 volt if the Zener diode is healthy. Next is the references of this presentation. So these are the references of this presentation. Like electronichub.org, electronics for you and electrical for use. So these are the references. And thanks for watching this video. Any doubt, anybody? Please ask me in Google Classroom. And again, thanks for watching this video.